Okay, now we just had a quiz where you were asked to do what I said last time you were asked to do. And you know, some people didn't quite get to watch the videos. Well, that means you're class behind, but I think I demonstrated to everybody what to do. I'm gonna do one up here. Can't even time me, okay? Just so you understand how this is done. Okay? It's quite simple. Once you learn it, last semester, nobody had any trouble doing this by the third day of class, okay? People were good at it. One person kept getting 1 point wrong, and it was, by the third day, it's either all right or it's all wrong. Because you have to get this precise. But one of the reasons for this exercise, one reason is you can construct these without using any numbers. That's important because these graphs exist whether the numbers are there or not. Okay. And the patterns these graphs represent in the real world are very important patterns that you apply throughout all kinds of fields. And if all you understand is the numbers, you probably don't understand the patterns. And it goes back to the fact that you've done numbers on a calculator since you were 3 years old or whatever, okay? And don't understand numbers very well. Reason, now some of you do, I'm sure, but most people don't. Just statistically, 80% of the people are seriously deficient in understanding numbers. Punch them into the calculator and take what it gives you. Now, some 20% of the people do manage to get a little beyond that, but the high school curriculum doesn't really require you to understand numbers. Okay? Just requires you to be able to pass an SOL test. And the SOL test ain't a great test. And there are a lot of things they should be testing that don't, but that's all tied up in politics and education schools. And I won't get off into that. Yeah. Education schools follow the latest fad. And as a result, well, it gets political. And I'm talking about academic politics, not national politics. So that was a digression. It really doesn't have much to do with anything. Point is, we start with this because we can't really start with numbers and arithmetic because people don't know it. Okay? How many of you could do the -2 power of 1/2? 1/2 to the -2. Fundamental, that's algebra 1, pre-algebra. Okay? People can't do it. It's not unusual for a class of this size that nobody can do it, but usually there's 1 or 2. Okay, who can? People think that 1 divided by 0 is 0. Yeah, I'm glad we'll see some heads shake there. Okay, but most people believe it, and most people will write it. So we can't start with arithmetic because you need arithmetic to do these graphs. If you're going to do them based on arithmetic, since people don't know the arithmetic, we can't do it by arithmetic. We're going to build the arithmetic from these graphs. And then we're going to see why the arithmetic is what it is, and you'll understand it. And in the meantime, we're going to develop some number sets. Okay? And we'll do some numbers today with this graph. Okay, so anyhow, we have a geometric way of constructing this graph. It can actually be constructed with a compass and straight edge. It can be rigorously constructed. You know what a compass and straight edge is. I don't know how that one got left out of the curriculum, but it did. Some marvelous mind, collection of marvelous minds, some cult within the education system. I don't know what it was. One of the dumbest things that's ever done, in my opinion. Of course, you could say I'm a little bit old school. That's the way I was educated. Okay. Okay, here's what we were quizzed on. Draw a rectangle. Draw a midline here and a midline here. From the right edge, go halfway to the midline. From the midline to the middle, go halfway. There, that's it, on that side. Then do the same thing on this side. Start at the left edge, go halfway to the middle. Now, there's some terminology with this. There's a document that's linked on your assignments page that you should read after we've done this. Don't bother reading it right now because it doesn't make sense unless you understand the process. Then you can read it and know what the words mean. If you start with the words and try to follow the instructions, 95% of the people are going to have a lot of trouble reading. Okay? It's not an easy thing to do. It's inherently a little more challenging. It's understanding the picture. What I just said is easy to understand. Make sure you understand it. We did it in gory detail last time. If you understand it now, that's great. Okay? If you don't understand it now, go back and look at the video from last time. Okay, then we start here and go halfway. Well, the midline is already halfway to the lower edge. It's called an edge or an endpoint, an edge subdivision. Okay, so here our target is down here. We go halfway, and then just like we did over here toward the middle, we go halfway toward the lower edge again, then halfway again, then halfway again, then halfway again. That's all there is to it. But make sure you know halfway. Okay, if these things aren't getting twice as close together every time, then you're not doing it right. And some of you are not quite seeing the algorithm. And if you're good at reading algorithms, you know, if you're like studying in computer stuff, might help you to read the algorithms and try to find them. Be good for your computer stuff, be good for this. And some people are. So there we have it. And then what do? We mark some points. We start in the upper left-hand corner, do one line to the right, two lines down, one line to the right, two lines down, one line to the right, yeah, and two lines down. Usually when I think I make a mistake, I haven't, and I didn't that time. I saw something I didn't like. Then one to the right and two up, one to the right and two up, one to the right and two up. There are my points. Okay. And then get a pretty nice parabola, if I do say so myself. It's one of my better efforts. Usually they're lopsided as heck. Okay, I do it quick, I do it better. All right. So there it is. That's our basic construction. That's construction of the squaring graph. Okay, of a square graph. That's a shape of a square graph. We don't have any numbers on it yet. We're going to put some numbers on it here in a minute. I'm going to do one more. Okay, that's it for the vertical lines. What's different about this and this? Now, don't say anything. You're not allowed to talk when the camera's running. Oh, come on. Oh, wait a minute. Cancel. I hit the wrong button. Well, you know, correctly identified. There are only 3 lines vertical here, and there are only 3 vertical lines here. I mean, there are 5 vertical lines here. So basically, I just go one step toward the middle and I'm done. And then from here, I go one step toward the middle and I'm done. It's a little easier than that one. Most of them, you're going to do 2 steps toward the middle. But for this one, you do 1 step toward the middle. Then we do the same thing vertically, except we do 1 fewer line. You don't need that last line. The last line is there not because we put a point on it, but because we want to maintain the pattern of 1 over and 2 down. 1 over and 2 down. And if this line wasn't here, we wouldn't have 2 lines to go down. That's the only reason for this line. We can subdivide more, and then we need 2 more lines here, and things will get really tight down toward the bottom edge. We don't need it. We see what the shape is. We can draw a nice curve with these points. We don't really need them. Okay. Over here, then we do this, and we'll end up with 4 lines instead of 1, 2, 3, 4, 5 inside the rectangle. Okay, then the pattern is really easy. Start here. Move over one, up one. Over one, up one. I think I'm gonna do next. Over one, up one, right? Over one, up one, over one, up one, and I make my curve. And there is your curve for compound interest in any investment. Or your curve for any population in an ecosystem where something is introduced like an invasive species and increases the rate at which it increases is proportional to how many there are. Okay, if you put a couple of guppies in a tank with plenty of food, you know what a guppy is? The little fish. They're easy to raise. They're kind of neat, but they get really crowded. Okay, before they get crowded, you got a couple of guppies in there, they reproduce, you get more guppies. And those guppies reproduce, and you get more guppies. The more guppies you got, the more new guppies you get. Up to the point where the tank starts getting too crowded, and then things kind of level off. So you have this curve that goes up like this, pretty much like this, until it starts leveling off, and you get the sigmoid curve, and we'll talk about that later. But for the early stages, with the first couple of guppies, it kind of goes like this. Now, my curve should have been a little lower here. It should have gone through here. It shouldn't have been as steep as it was here, but I do it carelessly. Okay. So you want to draw a better curve than I did. And I intentionally did that so you can do something better than I do. Well, a lot of you can draw better than I can, I'm sure. You see, it's pretty good drawings out there. Okay. So this is exponential shape. If somebody says something increases exponentially, that means it increases along a curve that looks like this. Not like this. It's not an exponential increase. Okay. All right. There's another shape that I might show you before the end, depending on how much time we've got. But what I want to do is I want to go back and we can do what I'm going to do here with either of these curves. Well, remember there's a red dot involved. Go back and look at what it happened last time. But for both of these, the red dot is at the midpoint of the lower edge, is the way I put it when I did the rules. Okay. Now I am going to show you one more just so we have a complete list. We have time to do that. I'm going to write it do a little smaller, but it's pretty simple. Just like this one, right? Makes sense? I mean, can you see that it's so? All right. Now, my red dot in this case is going to go in the middle of the rectangle. You could draw two diagonals, it's where the diagonals meet, but it's pretty close to the point that I made. Okay. Then I do an endpoint or an end division from here toward here. Well, no, I don't. What I do is vertically the same thing I did with horizontal lines. I do the same thing I did with vertical lines. I go from here halfway to the middle, and then from here halfway to the middle. So it's totally symmetric. And I do the same here. So if I rotated this 90 degrees, it would look exactly the same if it's done, yeah, real accurately in a square. Okay. Then the rule here is a little more complicated than this, but it's not bad. If you remember what the rule is, if you know what it looks like, you can usually kind of figure out where the points are going to go. You start at the left edge, one line below the middle. Okay, that would be here. Because here's the middle, here's one line below the middle, right? Then you go right one, down one. Then you go right one, down one. And then you're at the end of the rectangle. Okay. We're at the lower edge and you draw a curve. Is that hard? You got to remember where to start. But then the over one, down one, over one, down one, over one, down one works real well. Okay. Then what do? We go to the top edge, one line to the right of the middle. And then we go over one, down one, over one, down one, and we have this. Okay. Now we have two separate curves because we could extend this. We could make another line twice as far from the middle as this one down here, and we could make another line closer to the middle here and go over one, down one, and keep going over one, down one, over one, down one, and we would never get to the middle. If we keep going halfway to the middle, halfway to the middle, halfway, we never get to the middle, do we? You want to maybe process that idea, but for that reason, we don't connect anything on this side to anything on this side. Our pattern never gets us to the middle. So if you don't understand what I just said about why it never gets us to the middle, just accept it for now. Our pattern on the left would never get us to the middle if we extended it. And our pattern on the right would just keep having to start one line to the left, one line to the left. We'd never get to the middle. So we don't connect this point to this point. Okay. And that's why we can't divide by zero. Talk about that why later. Okay, division by zero is forbidden. Because this is our reciprocal graph. Now, if you can do these three graphs, and I expect you'll be able to do them by next time. If you can do these three graphs accurately and quickly, then there are 5 more graphs, but they'll all be easy. Okay, subdivisions. These are the 3 kinds of subdivisions we use for any regret. So you get those subdivisions, and then there's simple rules. Okay, just as simple as these. This is probably the most complicated rule as far as where you do the points, but it's not hard to understand this. So there it is. Okay, so I've just asked everybody to sketch an X and Y axis quickly. I think people have done that. I think when I look out there, I see a lot of X and Y axes. Then I want you to mark a point on the X axis somewhere to the right of the origin. Can you do that? Put a point on the X axis somewhere to the right of the origin. Okay, in a coordinate system, points that lie directly above or below other points have the same X coordinate. Okay, so if I draw a point here, it's got the same X coordinate, it's directly above this point. As best I could do it. Okay. I could draw another one down here. Matter of fact, I can draw a line here, draw as many points as I want in the line. Okay, they all have same X coordinate. Okay. Okay, pick one of the points that you drew, not the one on the X axis. And pick one of those points and draw a couple of points that have the same Y coordinate. I think I didn't get it right away. So pick a point, right? I'm not being critical. If you pick 2 or 3 points and you do the same Y coordinate, you know what a Y coordinate is. That's really what's important. But we're going to pick 1 point, and we're going to do the Y coordinate. Okay, so I'm going to pick this point. And I'm going to draw a couple of points. Here's a point. Here's a point. Here's a point. All these points have the same Y coordinate, don't they? All these have the same Y coordinate. You got to understand what it means to be an X coordinate and a Y coordinate. Now, if we have a scale on this, I say that 32 is right here, then you estimate maybe that's 27. The X coordinate would be 27, right? If I say 128 is here, you say, okay, that's 128, that's maybe 94.3286, don't you think? Okay, yeah. You could estimate. And we're gonna do a lot of estimating. We'll do estimating with these graphs. Okay. So let's just do that. Let's say that 32 is here. And we're gonna say, okay, this line looks like X is 27 at every point on the line, right? On a vertical line, every X value is the same for every point. Okay, if 128 is here, and maybe this is Y equals 94. Now you can go to the video and take your ruler and say, tell me if my proportions are right. And I guarantee you they aren't completely right. It's just ballpark. Okay. I wasn't being real careful about it. It actually looks like about 2/3 of the way. 2/3 of 128 would be 86 and 2/3, something like that. Be a little less than 94. It's no big deal. Okay, you understand what I mean by saying X equals 27 everywhere in this line and Y equals 94 everywhere on this line. Okay, so the coordinates of this point (27, 94). Now, this is something you should be totally familiar with when you come into this course. But we got to go over it because not everybody had a course that made them really think about what this is, although I see evidence that many of you did. Okay. And maybe you had a course and maybe you were too busy playing football. Okay, or too much thumb typing on a device. For various reasons, maybe you didn't get it all. Well, time now to get it all. Make sure we get all the details. Okay. Now I'm gonna make another pretty picture. I've got room on this board. Alkaline. All right. Here we go. That's a little off center. Okay. But it's still going to serve its purpose for illustration. Okay. Now you can even draw that picture about as fast as I did. But you probably need a little more practice. You know, I've had plenty of practice. So. Okay, now I've got some dotted lines here. Notice that these dotted lines go through the edges of this rectangle. Notice also that this rectangle is supposed to have a red dot look to the base. And there's my squaring shape. It's a little skewed, it's a little off center. It's not as symmetric as it ought to be, because I didn't do a real good job of it. A little to the left of this point, a little more to the left of this. Didn't really hit the red dot at the bottom. Okay. And you want to try to do better, but you don't have to be all that artistic. Still going to get pretty good results if you're even halfway careful. Okay, now I'm going to say that this line is x equals 8. And this line is x equals 12. And this line is y equals 20. And this line is y equals 16. So now we can see how big this thing is, whatever that scale means. Okay. Now, what I want you to do is tell me label this line. This line's been labeled y equals 20, label this line. And then label this center line here. Okay, a lot of smart people didn't quite hear what I said. Okay, there's some smart people in here. Said label this center line. Okay, what do you mean by label this center line? Well, this line's labeled. What's the label? Y equals 20, right? What's this line? It's labeled. It's y equals 16. So what is this line? Y equals what? And once you get that one, go ahead and see if you can label the rest of the horizontal lines. But at least get the middle one. Okay. That's pretty good. But a couple of mistakes, you know, some people want to go 20, 19, 18, 18, 16, 15. Uh-oh, there's 16. Something's wrong, right? And another thing, if you would, like 19, 18, 17, this is a strong tendency. This is one reason I do this by subdivision is people don't seem to understand that if lines are closer together, there's got to be less space between the numbers. I see a lot of it. I see people labeling an x-axis like this. Here's 10, here's 11, here's 12, here's 13. Okay, you see what's wrong with that? Yeah, the distance between here and here is 1. Distance between here and here better be 1, but this distance looks like less than this distance. That's wrong. Okay. And I see a lot of that. I said 30% of the students will do that. They'll just put consecutive numbers on any points that pop up. Okay, so one way of getting around that is to do this thing by subdivision. Okay, so if you subdivide, we got 20 here and 16 here. This is twice as well. This is halfway between these two. What's halfway between 16 and 20? Well, everybody can see, I think, that that's 18. Okay, now you can label the rest of them. What would this be? Show me with figures. It's a 2-digit number. If you think it's 32, right, 32. What do you think the number is here? Show me your fingers. What's the first digit? Yeah, I mean, first digit. First digit, here's 1, here's 1, here's, well, here it's 2, right? First digit is 1. Gotta be because it's between 1, 6 and 1, 8, right? From 16 to 18. What's the second digit? Halfway between here, it's going to be 17, right? Okay, when I tell you to put up fingers, do it. And be careful which finger you put up. I don't take offense easily, but you know. Okay, now, so what's halfway between this and this? This is halfway between here and here. What's halfway between 16 and 17? Write it in your paper. Just write a number, just circle a number that you think is halfway between 16 and 17 and circle it on your paper. And let me pause the video while I see how you did. Okay, most of you wrote 16.5, and that's okay. But I'm gonna write it at 16 and a half. Okay? Now, what's halfway between 16 and 16 and a half? It's 16 and a fourth, which you could write as 16.25. Okay, but if we keep going, what's halfway between 16 and 16.25? It's easier to write down what's halfway between 16 and 16 and a quarter. That would be 16 and an eighth. Okay? And what's and that's 16.125. What's halfway between 16 and 16.125? 16.0625. Okay? You're going to remember that? Do you know that? No, but you can write this is 16 and a fourth. A fourth has more meaning than 0.25, although you know perfectly well that 2.25 means a fourth. Okay? Go 4 times as close. If we keep subdividing, we get fractions. We don't want to write these fractions as decimal. We can always convert them to decimals. Calculator will do that for you, okay? If you know, what's 16 and 1/64th? That's what you get after 3 more steps. Okay? I can't even tell you off the top of my head what 1/64th is, but I calculate it pretty easily. Okay? 36, 64. Okay, well, anyhow. That's how we label things, not with decimals, with fractions. Okay, another thing is, if we solve an equation later, then we get decimals. We don't get decimals, we get fractions. Okay, write the fraction, write the exact solution, because the decimals often are rounded off. Now you get your calculator, it gives you something this long, and you round it off to 2 or 3 significant figures. Well, that's a good approximation. Write the actual solution, and then say this is approximately equal to whatever your calculator says. Okay? So I just kind of keep that in mind. I'll stress that a little more when we get there. Okay, well, we can similarly label these lines. This is x equals 10. This is x equals 11. This is x equals 9, 10, 11, 12. And up here, I don't have a lot of room down below. This is x equals 10 and a half. And this is x equals 9. Sorry, it's, yeah, 9 and a half. Okay. So I've got all these lines labeled. So okay. Now on your graph, can you label the coordinates of the 7 points that we just drew? I wasn't recording when I did all that. I wrote down the coordinates of 2 points, 820, 917, and 17 is a little hard to read. 10 and a half, 16 and a quarter, 1220, and you've got a few others. And people were doing a good job of labeling. And I think you got an insight that most of you probably didn't have about what the coordinates mean. Okay, not that you couldn't have plotted the coordinates, but there's something here about how you can construct a graph with a pretty accurate scale and draw some inferences from it. Okay, predict things and verify things. Okay, so this is my function. And actually, I'm going to use function notation here. We haven't talked about it. Something you should know coming into this course, but we're going to go over it. Okay. So if you don't, we'll explain it. Or look at the very beginning of the MDE 61, first 10 minutes. We do a lot with function notation. Yeah, we did it there because some of those students are in a distance class that didn't observe the snow schedule. Okay, and the snow closings, it just went right ahead. And that's fine, that's exactly what you need to do there, but it's got us out of sync in that class. So we had to do some stuff a little bit early for this class, but it's good stuff. Those videos are pretty much always worth looking at if you're not 100% sure of everything. Okay, so anyhow, so we have this, okay. So back to 20, what's the value of Y? Here's Y. You plug in for X and evaluate. Sorry, we don't have X equals 20. With the first number I saw. Let's say if X equals 12. What do you get for Y? Write it out for me. Okay, so what almost everybody did. They can just write this out with. You know that X equals 12, you write out this expression, replacing X by 12. Okay? And in fact, you can say a little more just to get used to the notation, whether you understand it totally or not. You'll understand it better if you go ahead and start using it without having to really understand it. And you don't even have to use it. Leave myself enough room, but I said Y equals F of 12. Okay, because what I've done is I replaced X by 12. I've replaced X by 12 in this expression. This is what I get. F of 12 equals 12 minus 10 squared plus 16. So I just went into this whole expression. I wrote the whole thing out. So let me write it out here too. Then we can write it like this. If that makes sense to you, then you're way ahead on function notation. If it doesn't, don't worry about that. We'll just worry about this, because that's all we're going to do now. 12 minus 10 is 2. Okay. And look here, we got the point 820. Okay. By some miracle that you'll understand in a week or so, we can, from this picture, we can write down this function and it's going to match if we do it correctly. Okay. Okay, well, what I want you to do now is I want you to estimate, first of all, sketch the line. X equals 11.3. Wherever you think that line ought to be. Okay, almost everybody did a really nice job. 11.3, that's between 11 and 12, you probably understand. And 11.3 is closer to 11 than it is to 12, right? So you're gonna draw a line, maybe. Here. Yeah, label it X equals 11.3. Okay. Now, what's the Y coordinate of that line? Draw the Y equals whatever line that goes through that point. Where the, but, okay, again, the point where this line hits the curve. As you drew it. Okay, so most of you got a number between 17 and a half and 18. And that's probably about right. If I do my graph, here's the point where this 11.3 line hits. This looks like about y equals 17. You know, it's a little more than 17.5, about 17.6. That's an estimate based on my graph. Now, my graph isn't that great, but it did pretty well at this point, midpoint. So with luck, that might be a good estimate. But we can plug that estimate in to the formula. We drew those lines, we did all that, right? Okay, so I estimated y equals 17.6. Most of you were within a few tenths of that. Okay, some people are a little over 18, just depends on how you drew your graph. And, you know, you're not experts at drawing the graphs, but since your results were so consistent, you're pretty darn good at it already. And we'll see how my estimate works. And then check yours and see if you can show off and get a better one. Okay, see if you got a better one. So we're out of time, so I'm gonna do this real quickly. Y equals f of 11.3, which would be 11.3 minus 10 squared plus 16. Oh, man. I didn't quite nail it. That was close. Okay, this gives me 1.3 squared, because of course, subtract 10 from 11.3, you get 1.3 plus equals 16. That's 1.69 plus 16, which is 17.69. And that's more significant figures. 17.7. Okay. So mine came out really close, but of course it's a hand sketch graph. And I didn't sketch it all that carefully, but I wouldn't expect to get much closer than that most of the time. Okay. Okay, so if you estimated 17.5, I think I saw somebody estimate 17.7. I know I saw 17.8. Then you're going to be pretty close. When you plug the number in here, it's going to pretty well confirm the graph. So by some miracle, this graph seems to match this function. All right. Now we could also, if y equals 18, then what should x be? Okay, so we do the draw the y equals 18 line, come down here and estimate maybe it's 11.5. And then we could set this expression equal to 18 and solve the equation to find x, and it's not that hard to solve. So we get into a little bit of algebra. So we're doing arithmetic, we're doing algebra, we're doing some function notation already, and relating it to these graphs. Okay. Okay. Y'all are doing good. It was a good session for you.